Okay, what is fault tolerance? As we discussed yesterday, we have seen a block has been replaced. I mean, replicated, not replaced. It is a replicated thrice, right? By default, it is getting replicated three times. Why we are replicating the same data three times in the cluster? The only the reason is to achieve the fault tolerance. Let's assume in a cluster I have stored the data. The replication factor is only 1. Let's assume that replication factor is 1. I didn't store the backup. It's ideally it's a backup. I didn't store this backup into any of the other machines. And suddenly something happened to that machine. The machine is failed, or it is it's failed with respect to hardware. Then can we get the backup of it? That is a valuable information. Let's assume that that is some information which is generated by the financial institutes, so that data is valuable data, and the system is failed. So can I get the data? No, I cannot get the data because the data has been stored only one machine. That machine is failed, so I may not be able to get the I cannot able to recover the data. To avoid these kind of situations, Hadoop come up with a beautiful feature called replication factor, or you can say fault tolerance. So what Hadoop's, we all knows that Hadoop uses the commodity hardware for the cluster, right? And here the commodity hardware means which is bit cheap hardware compared to the high-end systems. We no need to use the high-end systems in the cluster. We can use the commodity hardware where you can buy from HP, IBM, some other Dell. So from these vendors. No, the organizations treat it as the data is more valuable than the hardware, commodity hardware. That is the reason Hadoop come up with the uh, duplicate or replicate the data thrice. Okay. The- so that is the reason by the default the Hadoop come up with the replication factor is 3. It means that when you store the data, let's say when you're storing the data 1 GB into the cluster, that will be replicated into cluster thrice. It will become a 3 GB. So here people may ask, sir, it is a redundancy. Why we need to store thrice? One thing is the very first reason in a cluster we are using the commodity hardware where the data is more valuable than the commodity hardware. That is one reason. The second reason is if any data node failure, we can easily recover the data, right? So, sir, it is a fixed, or I can change the replication factor. Yes, you can change the replication factor. It's a depends on your cluster size and depends on how valuable your data is. Okay. Any doubts? Okay. If you have a multiple replications, if you have a multiple replications like 3 replications, let's assume I have submitted a job. I am processing some data. Okay. There are three blocks has been generated for my file, and those 3 blocks has been spreaded across the cluster, and I started processing the data in 3 blocks. 2 blocks are processing the data very fast, and one block, I mean one machine, is taking so much of time. And one machine is taking so much of time, still other machines, I mean other blocks where is stored, those machines are finished 80% of the data, 80% of the processing the data, but still one data node, it is still processing, which is still showing 5% or 10%. Then what name node will do, it will calculate the what it name node will do, it will observe, okay, these guys are finished fast and this guy is taking so much of time, better this guy might have some problem with this data node, so better launch the same job in other machine where that block is available. So then it will launch the other job in other data node. Then here for one block, 2 jobs are parallelly running. For the same data, 2 jobs are parallelly running. Then whoever finishes first, it will consider that output as a final output. Other one will be killed. Other job will be killed. It can be a first job, it can be a second launch job. This launching the job, this process is called speculative execution. This process is called speculative execution. Let's assume if you have only one block, you come across this situation. Can you able to do this? Can you able to launch the same job in other data node? No, we cannot able to. Why? Because we have only one block which is stored in only one machine. Let it take. We have to wait to finish the job. It may fail in between. We may end up with taking so much of time to process the small amount of data. So because of these three reasons, these three reasons, the Hadoop come up with replication factor, where you can store the data in three places. Even if the data is one data node fail, you can recover the data. Other reason is when you are processing the data, if any data node is taking so much of time, the same job can be the same task can be performed in other data node where you can execute fasterly. Okay, clear these doubts, guys? Okay, so any other doubts about the replication? I'll just try to answer. Okay, what about other guys? Okay, and one interview question, guys. Okay, while storing a data, while storing the data into cluster, can I mention, can I define my own replication factor? Yes, you can specify your own replication factor while storing only, like hdf hadoop fs hyphen d. If you see the option here, the same, the fs hyphen put, sorry, let me repeat the command. Hadoop fs hyphen d dfs dot replication equal to some number, whatever the number you feel, and hyphen put or hyphen copy from the local, then you give the destination, source and destinations. Okay, and also the same, can I specify the block size while putting the data into hdfs? Can I specify the block size while storing the data into hdfs apart from the default configuration? Yes, you can override the any configuration which is as defaultly specified. You can override it by putting the command, by while you are submitting the job, like hadoop fs hyphen d dfs dot replication equal to, you can say 3, you can say 4, whatever you wish. It depends on the data, uh, value of the data or importance of the data. You can take care of it. Hyphen put, give your source path and destination path. Okay, these commands we'll see in detail while we are executing the commands. And the same way you can specify the block size also. Hadoop fs hyphen d, and you give the configuration name and value. Then you can specify the source and destination path. Any doubts, guys? Yes, this session is getting recorded. Okay, next, what is the high throughput? As I mentioned yesterday, as I mentioned yesterday, if you store a huge amount of data in the cluster, when you run the job, the data is getting processed parallelly. So you will get the results very quickly. Okay, I have processed 1 TB of data. How much time it is taking? It is taking 3.5 minutes. Fine, very good. So I'm getting the high throughput from the out of the cluster. If you go with the normal approach, a traditional approach, it may end up with the hours or often more than hours. Right? Why we are getting high throughput? Because of the parallel processing. The Hadoop suits for the big files, or Hadoop suits for the larger files. So Hadoop is not suit for the large number of the small files. Why it is? We know that because for each small file, and each small file will be divided into blocks, or each small file less than a block, what will happen? Each small file has to give an entry in the name node. So if we have a 1 lakh or 2 lakhs of the small files, that your name node will be more burden. The name node will be having so many entries in their fs image and edit logs, and it has to maintain the so many no entries. So it is a burden to your name node. So that is the reason Hadoop is suits for the big data, huge amount of the data. Okay, any doubts? I'm just moving to next slide. Okay, what is commodity hardware? Yeah, I'll tell you checksum, Chandu, while I'm talking about while inserting the data. Not only checksum, there is one more thing called CRC. I will talk about that as well. While we are putting the data into the HDFS, we'll see them in detail. Okay, so what are the Hadoop modes? There are different kind of data modes in the Hadoop. One is a standalone mode, pseudo distribution mode, and fully distribution mode. What is the difference? Pseudo distribution mode is like in one machine only we'll see all the demos will be running. I mean, will one machine only we treat uh, name node is the same machine only, and data nodes also in the same machine. But when it comes to the fully distributed mode, each process, or each, I can say, each daemon will be separated, and the name node will be running in the same data different machine, and data node will be running in the different machine, and the secondary name node will be in the different machine. By default, in real times, we will not use the pseudo distribution modes. We will use only fully distributed mode. Okay, pseudo distribution mode we will use for only development. Okay, so in the real time, we will be having the different kind of clusters, like testing cluster, production cluster, and development cluster. Okay, so we will be having a different kind of data as well for the development, because we will be doing trial and error. We may corrupt the data, so the development development team will have their dedicated database. I mean, dedicated data with them. When it comes to testing people may also check on the same kind of data, or they may generate the new data. They will test on it, whether if they when they are going to test whether how the performance of the cluster, how this MR job or Hive job, or what a processing job is running, how it is running, how long it is taking. The testing team will upload the data either manually or directly. They will take the data and put into the cluster. They will start, testing it. And the production cluster will be four or three more than three times bigger than our development cluster or testing cluster. Production cluster will be the huge cluster which will be running, keep on running. Okay, normally always the production cluster will be bigger cluster than your development and QA test cluster or your testing cluster. Any doubts? Okay, as I said, what is the pseudo distribution mode and what is the fully distribution mode. And now we have come to the installation part. So the installation part is like, so depends on the configuration what you are using for uh, for your local pseudo distribution mode, or when it comes to the fully distribution mode, we will not use any virtual machines there. In the fully distribution mode, all the nodes or all the computers will be having a Linux flavor OS in that. Then we will install the Hadoop on them. Then we'll run then we'll run job on that. It's a fully distributed mode. Like your name node will be separated, and your secondary name node will be separated, and your data node will be separated. Okay, and the job tracker and task tracker will come into picture when we are talking about MapReduce. We'll see them in later point of time, and these will be running on differently. Okay, and what is a SSH? It's a secure shell. It is a secure shell. Why we need a secure shell? When you want to talk to other data node or other machine from your local machine, you need a securely log into that. For that, we need authentication. The secure shell, what we will do, we will generate one public key, and we'll put into that both the machines. I mean, we'll give to the administrator person will be put in there as well. So when you're talking to that machine, the public key will be cross checked, and if both are same, then only it will allow to talk to that machine. If you are not, your machine public key is not registered there, then it will throw an exception saying you are not authenticated to do that. Okay, and in your machine that SSH should be installed, and Java should be installed in your machine, because the Hadoop framework has been designed and developed by using Java only. To run your Hadoop, we should have a Java, but that is a constraint. Your Java version should be 1.6 and later. If you are using your 1.6 below 1.6, it will not run the Hadoop cluster. I mean Hadoop will not execute in your machine. It should be 1.6 onwards. The version should be 1.6 onwards. Any doubt, guys? Yes, it's okay. Yeah, I hope from here and all, these are the installation parts. So shall we go for the installation, or how? Or we can go ahead and discuss some other topic. It's up to you guys. If you are ready with your computer handy, and we'll just go with the setup. So I can stop the recording here because there is not.